Hey there, aviation enthusiasts. Today, we're diving into the fascinating world of the F-22 Raptor, a cutting-edge fighter jet that has captivated the minds of many. The F-22, also known as the Raptor, is a single-seat, twin-engine, all-weather stealth fighter aircraft. It was designed to perform air superiority missions and has a top speed of Mach 2.25. Developed by Lockheed Martin and Boeing, the F-22 was first unveiled in 1993. Its design was influenced by the YF-23, which was a competitor in the Advanced Tactical Fighter program. The F-22 has a unique design that allows it to achieve supersonic speeds without using afterburners. It's equipped with advanced avionics, radar, and weapon systems, making it a formidable fighter jet. The F-22 has a few variants, including the F-22A, F-22B, and F-22C. It has been operated by the United States Air Force since 2005 and has seen action in various conflicts. Sadly, there have been a few accidents involving the F-22, but it remains a remarkable piece of aeronautical engineering. If you're interested in learning more about the F-22, be sure to check out the F-22 Raptor page on our website. And if you're a fan of aviation history, don't forget to follow and subscribe for more exciting content. Thanks for tuning in. The Lockheed Martin Boeing F-22 Raptor is an American twin-engine, jet-powered, all-weather, supersonic stealth fighter aircraft. As a product of the United States Air Force's Advanced Tactical Fighter ATF program, the aircraft was designed as an air superiority fighter, but also incorporates ground attack, electronic warfare, and signals intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22 airframe and weapon systems and conducted final assembly, while program partner Boeing provided the wings, aft fuselage, avionics integration, and training systems. First flown in 1997, the F-22 descended from the Lockheed YF-22 and was variously designated F-22 and F-A-22 before it formally entered service in December 2005 as the F-22A. Although the U.S. Air Force USAF had originally planned to buy a total of 750 ATFs to replace its F-15 Eagles, it later scaled down to 381, and the program was ultimately cut to 195 aircraft to 187 of them operational models in 2009 due to political opposition from high costs, a perceived lack of air-to-air threats at the time of production, and the development of the more affordable and versatile F. The last aircraft was delivered in 2012. The F-22 is a critical component of the USAF's high-end tactical air power. While it had a protracted development and initial operational difficulties, the aircraft became the service's leading counter-air platform against peer adversaries. Although designed for air superiority operations, the F-22 has also performed strike and electronic surveillance, including missions in the Middle East against the Islamic State and Assad-aligned forces. The F-22 is expected to remain a cornerstone of the USAF's fighter fleet until its succession by the Boeing F-47-34. Origins, main articles, Advanced Tactical Fighter and Lockheed YF-22. The USAF published an ATF request for information referred to the aerospace industry in May 1981. And following a period of concept and specification development, the ATF System Program Office issued the Demonstration and Validation (DEM)-VAL request for proposals RFP in September 1985, with requirements placing strong emphasis on stealth, supersonic cruise and maneuver. The RFP saw some alterations after its initial release, including more stringent signature reduction requirements in December 1985 and the addition of the requirement for flying technology demonstrator prototypes in May 1986. And 310 owing to the immense investments required to develop the advanced technologies, teaming among companies was encouraged. Of the 7 bidding companies, and for Lockheed and Northrop were selected on the 31st of October 1986, and 5 Lockheed, through its Skunk Works division at Burbank, California, teamed with Boeing and General Dynamics, while Northrop teamed with McDonnell Douglas. These 2 contractor teams undertook a 50-month DEM-VAL phase, culminating in the flight test of 2 technology demonstrator prototypes, the Lockheed YF-22 and Northrop YF-23. While they represented competing designs, the prototypes were meant for demonstrating concept viability and risk mitigation rather than a competitive fly-off. And 6 concurrently, Pratt & Whitney and General Electric competed for the ATF engines, 14-15. Evolution of the F-22 design from 1987, with the bottom being the production configuration. DEM. VAL was focused on system engineering, technology development plans, and risk reduction over point aircraft designs. In fact, after downselect, the Lockheed team completely redesigned the airframe configuration in summer 1987 due to weight analysis, with notable changes including the wing planform from swept trapezoidal to diamond-like delta and a reduction in forebody planform area. 1617. The team extensively used analytical and empirical methods including computational fluid dynamics and computer-aided design, wind tunnel testing 18,000 hours for DEM, VAL, and radar cross-section, RCS calculations and pole testing. Avionics were tested in ground prototypes and flying laboratories, 18 during DEM, VAL. The SPO used trade studies from both teams to review the ATF system specifications and adjust or delete requirements that were significant weight and cost drivers while having marginal value. The short takeoff and landing stall requirement was relaxed to delete thrust reversers, saving substantial weight. Side-looking radars and the dedicated infrared search and track (IRST) system were eventually removed as well, although space and cooling provisions were retained to allow for their later addition. The ejection seat was downgraded from a fresh design to the existing ACES II. Despite efforts by both teams to rein in weight, the takeoff gross weight estimates grew from 50,000 to 60,000 pounds, 22,700 to 27,200 kilograms, resulting in engine thrust requirement increasing from 30,000 to 35,000 lbf 133 to 156 kilonewtons class. 19. Each team built two prototype air vehicles for DEM, VAL. 1. The YF-22 had its maiden flight on the 29th of September 1990 and, in testing, successfully demonstrated supercruise, high angle of attack maneuvers, and the firing of air-to-air missiles from internal weapons base. After the flight test of the demonstrator prototypes at Edwards Air Force Base, the team submitted the results and their full-scale development design proposals, or preferred system concept, in December 1990. On the 23rd of April 1991, the Secretary of the USAF, Donald Rice, announced the Lockheed team and Pratt & Whitney as the winners of the ATF and engine competitions. 20 both designs met or exceeded all performance requirements. The YF-23 was considered stealthier and faster, but the YF-22, with its thrust vectoring nozzles, was more maneuverable as well as less expensive and risky, having flown considerably more test sorties and hours than its counterpart. 2122. The press also speculated that the Lockheed team's design was more adaptable to the Navy Advanced Tactical Fighter net for replacing the F-14 Tomcat, but by fiscal year FY 1992, the U.S. Navy had abandoned an ATF due to cost. 23. Full-scale development. The program formally moved to full-scale development, or engineering and manufacturing development, E&D, in August 1991. The production F-22 design internally designated Configuration 645 had also evolved to have notable differences from the YF-22, which was immature due to being frozen relatively soon after the complete redesign in the summer of 1987. And 7. While the overall layout was similar, the external geometry saw significant alterations. The wing's leading-edge sweep angle was decreased from 48 to 42, while the vertical stabilizers were shifted rearward and decreased in area by 20%. 25. The radome shape was changed for better radar performance, the wingtips were clipped for antennas, and the dedicated air brake was eliminated. To improve pilot visibility and aerodynamics, the canopy was moved forward 7 inches 18 centimeters, and the engine inlets moved rearward 14 inches 36 centimeters. The shapes of the fuselage, wing, and stabilator trailing edges were refined to improve aerodynamics, strength, and stealth characteristics. The internal structural design was refined and reinforced, with the production airframe designed for a service life of 8,000 hours, 20 for 26. The revised shaping was validated with over 17,000 additional hours of wind tunnel testing and further RCS testing at Helendale, California and the USAF Rascat range before the first flight. Increasing weight during EMD due to demanding ballistic survivability requirements and added capabilities caused slight reductions in projected range and maneuver performance. 27. Manufacturers of the F-22. The roughly equal division of work amongst the team largely carried through from DEM, VAL to EMD, with prime contractor Lockheed responsible for the forward fuselage and control surfaces, General Dynamics for the center fuselage, and Boeing for aft fuselage and wings. Lockheed acquired General Dynamics fighter portfolio at Fort Worth, Texas in 1993, and thus had the majority of the airframe manufacturing, and merged with Martin Marietta in 1995 to form Lockheed Martin. While Lockheed primarily performed DEM, VAL work at its Skunk Works sites in Burbank and Palmdale, California, it shifted its program office and EMD work from Burbank to Marietta, Georgia, where it performed final assembly. Boeing manufactured airframe components, performed avionics integration and developed the training systems in Seattle, Washington. The EMD contract originally ordered 7 single-seat F-22s and 2 twin-seat F-22Bs. Although the latter was cancelled in 1996 to reduce development costs and the orders were converted to single-seaters, 33 the first F-22A, an EMD aircraft with tail number 91401, was unveiled at Air Force Plant 6 in Dobbins Air Reserve Base in Marietta on the 9th of April 1997, where it was officially named Raptor, an 8. The aircraft first flew on the 7th of September 1997, piloted by Chief Test Pilot Alfred Paul Metz, and 935-36. The Raptor's designation was briefly changed to F-22 starting in September 2002, mimicking the Navy's F-18 Hornet, and intended to highlight a planned ground attack capability, amid debate over the aircraft's role and relevance. The F-22 designation was reinstated in December 2005 when the aircraft entered service. 3738. Rear. Starboard view of aerial refueling tanker transferring fuel to a jet fighter via a long boom. The two aircraft are slightly banking left. An EMD F-22 refuels from AKC-135 during testing. The attachment on the back top is for a spin recovery chute. The F-22 flight test program consisted of flight sciences, developmental test DT, and initial operational tests and evaluation IOT&D by the 411th Flight Test Squadron FLTS at Edwards AFB, California, as well as follow-on OT and development of tactics and operational employment by the 422nd Test and Evaluation Squadron TES at Nellis AFB, Nevada. 9 EMD jets assigned to the 411th FLTS would participate in the test program under the Combined Test Force CTF at Edwards. The first 2 aircraft conducted envelope expansion testing, such as flying qualities, air vehicle performance, propulsion, and store separation. The third aircraft, the first to have production-level internal structure, tested flight loads, flutter, and store separation, while 2 non-flying F-22s were built for testing static loads and fatigue. Subsequent EMD aircraft and the Boeing 757 FTB tested avionics, environmental qualifications, and observables, with the first combat-capable Block 3.0 software flying in 2001. 39 air vehicle testing resulted in several structural design modifications and retrofits for earlier lots, including tail fin strengthening to resolve buffeting in certain conditions. 40 Raptor 4001 was retired from flight testing in 2000 and subsequently sent to Wright-Patterson AFB for survivability testing, including lead fire testing and battle damage repair training. 41 other retired EMD F-22s have been used as maintenance trainers. 42. An EMD F-22 of the 411th FLTS flies over Edwards AFB, California, in 2018, because the F-22 had been designed to defeat contemporary and projected Soviet fighters. The end of the Cold War and the dissolution of the Soviet Union in 1991 had major impacts on program funding. The DoD reduced its urgency for new weapon systems, and the following years would see successive reductions in its budget. This resulted in the F-22's EMD being rescheduled and lengthened multiple times. Furthermore, the aircraft's sophistication and numerous technological innovations required extensive testing, which exacerbated the cost overruns and delays, especially from mission avionics. Some capabilities were also deferred to post-service upgrades, reducing the upfront cost but increasing total program cost. 4340 for the program transition to full-rate production in March 2005 and completed EMD that December, after which the test force had flown 3,496 sorties for over 7,600 flight hours. 41, as the F-22 was designed for upgrades throughout its lifecycle. The 411th FLTS and 422nd TES continued the DT-OTNEN tactics development of these upgrades. 42. Derivatives such as the X-40 for thrust vectoring research aircraft and the FB-20 to medium-range regional bomber were proposed in the late 1990s and early 2000s, although these were eventually abandoned. In 2006, the F-22 development team won the Collier Trophy, American aviation's most prestigious award. 45. Due to the aircraft's sophisticated capabilities, contractors have been targeted by cyberattacks and technology theft. 46. The USAF originally envisioned ordering 750 ATFs at total program cost of $44.3 billion and procurement cost of $26.2 billion, FY $1,985, with production beginning in 1990 for and service entry in the mid to 1990. Major Aircraft Review MAR led by Secretary of Defense Dick Cheney reduced this to 648 aircraft beginning in 1996 and service entry in the early to mid-2000s. After the end of the Cold War, this was further curtailed to 442 in the 1993 bottom-up review, while the USAF eventually set its requirement to 381 to support its Air Expeditionary Force structure, with the last deliveries in 2013. Throughout development and production, the program was continually scrutinized for its costs and less expensive alternatives, such as modernized F-15 or F-16 variants, were being proposed. Even though the USAF considered the F-22 to provide the greatest capability increase against peer adversaries for the investment. 47. However, funding instability had reduced the total to 339 by 1997, and production was nearly halted by Congress in 1999 and 10. Although funds were eventually restored, the planned number continued to decline due to delays and cost overruns during EMD, slipping to 277 by 2003. 4950. In 2004, with its focus on asymmetric counterinsurgency warfare in Iraq and Afghanistan, the Undersecretary Donald Rumsfeld further cut procurement to 183 production aircraft, despite the USAF's requirement for 381. 5150 to funding for this number was reached by a multi-year procurement contract awarded in 2006, with aircraft distributed to 7 combat squadrons. Total program cost was projected to be $62 billion, equivalent to approximately $90.2 billion in 2023. 53. In 2008, the Congressional Defense Spending Bill raised the number to 187.50 for 55. F-22 production would support over 1,000 subcontractors and suppliers from 46 states and up to 95,000 jobs, and span 15 years at a peak rate of roughly 2 airplanes per month, about half of the initially planned rate from the 1990 MAR. After EMD aircraft contracts, the first production lot was awarded in September 2000, 56, 57, 58 as production wound down in 2011. The total program cost was estimated to be about $67.3 billion, about $360 million for each production aircraft delivered, with $32.4 billion spent on research, development, test, and evaluation, RDT, and EN $34.9 billion on procurement and military construction in then-year dollars. The incremental cost for an additional F-22 was estimated at $138 million, equivalent to approximately $191 million in 2023. In 2009, 5960. In total, 195 F-22s were built. The first two were EMD aircraft in the Block 1.0 11 configuration for initial flight testing and envelope expansion, while the third was a Block 2.0 aircraft built to represent the internal structure of production airframes and enabled it to test full flight loads. 6 more EMD aircraft were built in the Block 10 configuration for development and upgrade testing, with the last considered essentially production-quality jets. Production for operational squadrons consisted of 70 for Block 10/20th training aircraft and 112 Block 30/35th combat aircraft, for a total of 186 or 187 when accounting for production representative test vehicles and certain EMD jets. And one of the Block 30 aircraft is dedicated to flight sciences at Edwards AFB 6162. By 2020, Block 20 aircraft from Lot 3 onward were upgraded to Block 30 standards under the Common Configuration Plan, increasing the Block 30/35 fleet to 149 aircraft, while 37 remained in the Block 20 configuration for training and 1260 for 65. Then on exports, 2 F-22s over flying snow-capped mountains, 2 F-22s during flight testing, the upper one being the first F-22 Raptor 4001. In order to prevent the inadvertent disclosure of the aircraft's stealth technology and classified capabilities to U.S. adversaries, 66-67 Annual Appropriations Acts since FY1998 have included a provision prohibiting the use of funds made available in each act to approve or license the sale of the F-22 to any foreign government. 68 customers for U.S. fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon or the newer F-35 Lightning II, which contains technology from the F-22 but was designed to be cheaper, more flexible, and available for export. 69. In September 2006, Congress upheld the ban on foreign F-22 sales. 70. Despite the ban, the 2010 Defense Authorization Bill included provisions requiring the DoD to report on the costs and feasibility for an F-22 export variant, and another report on the effect of export sales on the U.S. aerospace industry. 71-72. Some Australian defense officials and politicians have expressed interest in procuring the F-22. In 2008, the Chief of the Defense Force, Air Chief Marshal Angus Houston, stated that the aircraft was being considered by the Royal Australian Air Force RAAF as a potential supplement to the F-35. 73-70 For some defense commentators have even advocated for the purchase in lieu of the planned F-35s, citing the F-22's known capabilities and F-35's delays and developmental uncertainties. 75, 76, 77. However, considerations for the F-22 were later dropped, and the F-A-18E F Super Hornet would serve as the RAAF's interim aircraft prior to the F-35 service entry. 78. The Japanese government also showed interest in the F-22. The Japan Air Self-Defense Force JSDF would reportedly require fewer fighters for its mission if it obtained the F-22, thus reducing engineering and staffing costs. 79-80 With the end of F-22 production, Japan chose the F-35 in December 2011. 81. At one point the Israeli Air Force had hoped to purchase up to 50 F-22s in November 2003. However, Israeli representatives announced that after years of analysis and discussions with Lockheed Martin and the DoD, they had concluded that Israel could not afford the aircraft. 82 Israel eventually purchased the F-35. 83-84. Production termination. Throughout the 2000s, when the U.S. was primarily fighting counterinsurgency wars in Iraq and Afghanistan, the USAF's requirement for 381 F-22s was questioned over rising costs, initial reliability and availability problems, limited multi-role versatility, and a lack of relevant adversaries for air combat missions. 69-85. In 2006, Comptroller General of the United States David Walker found that the DoD has not demonstrated the need for more investment in the F-22. 86 And further opposition was expressed by Bush administration Secretary of Defense Rumsfeld and his successor Robert Gates, Deputy Secretary of Defense Gordon R. England, and Chairman of U.S. Senate Armed Services Committee SASC Senators John Warner and John McCain. 87-88. Under Rumsfeld, procurement was severely cut to 183 aircraft. The F-22 lost influential supporters in 2008 after the forced resignations of Secretary of the Air Force Michael Wynne and the Chief of Staff of the Air Force General T. Michael Mosley. 89. In November 2008, Gates stated that the F-22 lacked relevance in asymmetric post-Cold War conflicts. 90. And in April 2009, under the Obama administration, he called for production to end in FY2011 after completing 187 F-22s. 91. 2 F-22As in close trail formation. The loss of staunch F-22 advocates in the upper DoD echelons resulted in the erosion of its political support. In July 2008, General James Cartwright, Vice Chairman of the Joint Chiefs of Staff, stated to the SASC his reasons for supporting the termination of F-22 production, including shifting resources to the multi-service F-35 and the electric warfare EA-18G Growler. 92. Although Russian and Chinese fighter developments fueled concern for the USAF, Gates dismissed this, and in 2010, he set the F-22 requirement to 187 aircraft by lowering the number of major regional conflict preparations from 2 to 1. Despite an effort by Wins and Mosley's successors, Eichel Donnelly and General Norton Schwartz, to raise the number to 243. According to Schwartz, he and Donnelly finally relented in order to convince Gates to preserve the long-range strike bomber program. 9390 for after President Barack Obama threatened to veto further production, at Gates' urging. Both the Senate and House agreed to abide by the 187 cap in July 2009, 95-96. Gates highlighted the F-35's role in the decision, 97, and believed that the U.S. would maintain its stealth fighter numbers advantage by 2025 even with F-35 delays, 98. In December 2011, the 195th and final F-22 was completed out of 8 test and 187 production aircraft built. The jet was delivered on the 2nd of May 2012, 99-100. After production ended, F-22 tooling and associated documentation were retained and mothballed at the Sierra Army Depot to support repairs and maintenance throughout the fleet life cycle, as well as the possibility of a production restart or a service life extension program. SLEP 100-11. The Marietta plant space was repurposed to support the C-130J and F-35, while engineering work for sustainment and upgrades continued at Fort Worth, Texas and Palmdale, California. 100-105. The curtailed production forced the USAF to extend the service of 179 F-15C. This until 2026, well beyond its planned retirement, and replace those with new-build F-15EX, which had an active export production line that minimized non-recurring startup costs to maintain adequate air superiority fighter numbers. 106-107. In April 2016, Congress directed the USAF to conduct a cost study and assessment associated with resuming production of the F-22, citing advancing threats from Russia and China. 108. On the 9th of June 2017, the USAF submitted their report stating they had no plans to restart the F-22 production line due to cost-prohibitive economic and logistical challenges. It estimated it would cost approximately $50 billion to procure 190 for additional F-22s at a cost of $206 to $216 million per aircraft, including approximately $9.9 billion for non-recurring startup costs and $40.4 billion for acquisition, with the first delivery in the mid. The long gap since the end of production meant hiring new workers, sourcing replacement vendors, and finding new plant space, contributing to the high startup costs and lead times. The USAF believed that the funding would be better invested in its next-generation Air Superiority 2030 effort, which evolved into the Next-Generation Air Dominance NGAD. 109-105. Modernization and upgrades. The F-22 and its subsystems are designed to be upgraded over its life cycle via numbered increments and 13 and operational flight program MOF updates in anticipation for technological advances and evolving threats. Although this initially proved difficult and costly due to the highly integrated avionics systems architecture. 110. Amid debates over the airplane's relevance in asymmetric counterinsurgency warfare, the first upgrades primarily focused on ground attack or strike capabilities. Joint Direct Attack Munitions (JDAM) employment was added with Increment 2. In 2005, Van Small Diameter Bomb SDB was integrated with 3.1 in 2011. The improved APG-77B1 radar, which incorporates air-to-ground modes, was certified in March 2007 and fitted on airframes from Lot 5 onward, and 14112-113. To address oxygen deprivation issues, F-22s were fitted with an automatic backup oxygen system (ABOS) and modified life support system starting in 2012. 114. A Block 30 F-22A, Serial 06 for 132, of the 411th Flight Test Squadron test fires an AIM-9X in 2015. In contrast to prior upgrades, Increment 3.2 emphasized air combat capabilities with updates to electronic warfare, CNI, including Link 16 receive and geolocation, as well as AIM-9X and AIM-120D integration. 115. Fleet releases of the two-part process began in 2013 and 2019 respectively. Concurrently, OFP updates added automatic ground collision avoidance system, cryptographic enhancements, and improved avionics stability. Among others, 116-117 AMIDSJ-TRS terminal, which includes Mode 5 IFF and Link 16 transmit, receive capability, was installed starting in 2021. 118-32 to address obsolescence and modernization difficulties. The F-22's mission computers were upgraded in 2021 with military-hardened commercial off-the-shelf COTS Open Mission System OMS processor modules with a modular open systems architecture MOSA. Agile software development process in conjunction with an orchestration system was implemented to enable faster upgrades from additional vendors, and software updates shifted away from increments developed using the waterfall model to number annual releases. 119-120. F-22's fly information with the 757 FTB near Edwards at AFB. Additional upgrades being tested include new sensors and antennas, integration of new weapons including the AIM-60J ATM, and reliability improvements such as more durable stealth coatings. To dedicated infrared search and track IRST, originally deleted during DEM. VAL is one of the sensors added. 121-120 to 123. Other developments include all-aspect IRST functionality for the Missile Launch Detector MLD, and 15-man teaming multi-capability with uncrewed collaborative combat aircraft CCA or Lowell Wingman, and integration of the Gentex, Raytheon later Thales USA Scorpion helmet-mounted display HMD, and 1630 to 125 to preserve the aircraft stealth while enabling additional payload and fuel capacity. Stealthy external carriage has been investigated since the early 2000s, with a low drag, low observable external tank and pylon under development to increase stealthy combat radius. 126. The F-22 has also been used a platform to test and apply technologies from the NGAD program. 127. Not all proposed upgrades have been implemented. The planned multifunction, advanced data link MADL integration was cut due to development delays and lack of proliferation, while Block 20 aircraft from Lot 3 onwards have been upgraded to Block 30/35 under the Common Configuration Plan. Lockheed Martin in 2017 had also proposed upgrading all remaining Block 20 training aircraft to Block 30/35 as well to increase numbers available for combat. This was not pursued due to other budget priorities. 65. Aside from modernizations, the F-22 structural design and construction was improved over the course of the production run. For instance, aircraft from Lot 3 onwards had improved stabilators built by Vought. 128-129. The fleet underwent a $350 million structures repair retrofit program (SRP) to resolve problems identified during testing as well as address improper titanium heat treatment in the parts of early batches. 130-40. By January 2021, all aircraft had gone through the SRP to ensure full service lives for the entire fleet. 131-132. The F-22 has also been used to test 10 qualify alternative fuels, including a synthetic jet fuel consisting of 50/50 its mix of JPA and a Fischer-Tropsch process-produced natural gas-based fuel in August 2008, and a 50% mixture of biofuel derived from camelina in March 2011. 133-134. The F-22 Raptor is a fifth-generation air superiority fighter that is considered fourth-generation in stealth aircraft technology by the USAF. 135. It is the first operational aircraft to combine supercruise, supermaneuverability, stealth, and integrated avionics or sensor fusion in a single weapons platform to enable it to survive and conduct missions, primarily offensive and defensive counter-air operations, in highly contested environments. 37. The F-22's shape combines stealth and aerodynamic performance. Plan for and panel edges are aligned at common angular aspects, and the surfaces, also aligned accordingly, have continuous curvature to minimize the aircraft's radar cross-section. 136 is clipped diamond-like delta wings have the leading edge swept 42, trailing edge swept 17, a slight anhedral and a conical cambered, reduced supersonic wave drag. The shoulder-mounted wings are smoothly blended into the fuselage with firm empennage surfaces and leading-edge root extensions running to the carrot inlet's upper edges, where the forebody chines also meet. Flight control surfaces include leading-edge flaps, flaperons, ailerons, rudders on the canted vertical stabilizers, and all moving horizontal tail stabilators. For air braking, the ailerons deflect up, flaperons down, and rudders outwards to increase drag. 137.30. Owing to the focus on supersonic performance, area roll is applied extensively to the airplane's shape, and nearly all of the fuselage volume lies ahead of the wing's trailing edge to reduce drag at supersonic speeds. With the stabilators pivoting from tail booms extending aft of the engine nozzles. 138. Weapons are carried internally in the fuselage for stealth. The jet has a retractable tricycle landing gear and an emergency tailhook. 30 fire suppression system and fuel tank converting system are installed for survivability. 139-140. The aircraft's dual Pratt & Whitney F-119 augmented turbofan engines are closely spaced and incorporate rectangular two-dimensional thrust vectoring nozzles with a range of plus or minus 20 degrees in the pitch axis. The nozzles are fully integrated into the F-22's flight controls and vehicle management system. Each engine has dual redundant Hamilton standard full authority digital engine control FATIC and maximum thrust in the 35,000 L. The F-156 kilonewtons class. The F-22's thrust-to-weight ratio at typical combat weight is nearly at unity in maximum military power and 1.25 in full afterburner. The fixed shoulder-mounted carrot inlets are offset from the forward fuselage to divert the turbulent boundary layer and generate oblique shocks with the upper inboard corners to ensure good total pressure, recovery and efficient supersonic flow compression. 141. Maximum speed without external stores is approximately Mach 1.8 in supercruise at military, intermediate power and greater than Mach 2 with afterburners. And 17 with 18,000 pounds 8,165 kilograms of internal fuel and an additional 8,000 pounds 3,629 kilograms into 600-gallon external tanks. The jet has a ferry range of over 1,600 mi 1,840 miles. 2,960 kilometers, 144. The aircraft has a refueling boom receptacle centered on its spine and an auxiliary power unit embedded in the left wing root. 145. Rear view of jet aircraft in flight at dawn. Dusk above mountains. Its engines are in full afterburner, evident through the presence of shock diamonds. F-22 flying with its Pratt & Whitney F-119 engines on full afterburner during testing. The F-22's high cruise speed and operating altitude over prior fighters improved the effectiveness of its sensors and weapon systems and increased survivability against ground defenses such as surface-to-air missiles. 146, 147. Its ability to supercruise or sustain supersonic flight without using afterburners allows it to intercept targets that afterburner-dependent aircraft would lack the fuel to reach. The use of internal weapons bays permits the aircraft to maintain comparatively higher performance over most other combat-configured fighters due to a lack of parasitic drag from external stores. 148. The F-22's thrust and aerodynamics enable regular combat speeds of Mach 1.5 at 50,000 feet 15,000 meters, thus providing 50% greater employment range for air-to-air missiles and twice the effective range for JDAMs than with prior platforms. An 15150-151. Its structure contains a significant amount of high-strength materials to withstand stress and heat of sustained supersonic flight, respectively. Titanium alloys and bismalamine. Epoxy composites comprise 42% and 24% of the structural weight. The materials and multiple load path structural design also enable good ballistic survivability. And 15150-153. The airplane's aerodynamics, relaxed stability, and powerful thrust vectoring engines give it excellent maneuverability and energy potential across its flight envelope. Capable of 9G maneuvers at takeoff gross weight with full internal fuel. 143. Its large control surfaces, vortex generating chines and LERX and vectoring nozzles provide excellent high alpha angle of attack characteristics and is capable of flying at trimmed alpha of over 60 while maintaining roll control and performing maneuvers such as the Herbst maneuver J-turn and Tubachev's Cobra. 150 for vortex impingement on the vertical tail fins. It caused more buffeting than initially anticipated, resulting in the strengthening of the fin structure by changing the rear spar from composite to titanium. 155-156. The computerized triplex redundant fly-by-wire control system and FATIC make the aircraft highly departure-resistant and controllable, thus giving the pilot carefree handling. 157-148. The F-22 was designed to be highly difficult to detect and track by radar, with radio waves reflected, scattered, or diffracted away from the emitter source towards specific sectors, or absorbed and attenuated. Measures to reduce RCS include airframe shaping such as alignment of edges and continuous curvature of surfaces, internal carriage of weapons, fixed geometry serpentine inlets and curved vanes that prevent line of sight of the engine fan faces and turbines from any exterior view, use of radar-absorbent material RAM, and attention to detail such as hinges and pilot helmets that could provide a radar return. 136. The F-22 was also designed to have decreased radio frequency emissions, infrared signature and acoustic signature, as well as reduced visibility to the naked eye. 158. The aircraft's rectangular thrust vectoring nozzles flatten the exhaust plume and facilitate its mixing with ambient air through shed vortices, which reduces infrared emissions to mitigate the threat of infrared homing heat-seeking surface-to-air or air-to-air missiles. 159-160 additional measures to reduce the infrared signature include special topcoat and active cooling to manage the heat buildup from supersonic flight. 161-136. Compared to previous stealth designs, the F-22 is less reliant on RAM, which are maintenance-intensive and susceptible to adverse weather conditions, and can undergo repairs on the flight line or in a normal hangar without climate control. The F-22 incorporates a signature assessment system which delivers warnings, and the radar signature is degraded and necessitates repair. 150 for while the F-22's exact RCS is classified. In 2009, Lockheed Martin released information indicating that from certain angles, the airplane has an RCS of 0.001 square meters or 40 dBsm, equivalent to the radar reflection with steel marble. The aircraft can mount a Lüneburg lens reflector to mask its RCS. 160-163. For missions where stealth is required, the mission-capable rate is 60 to 270% and 20. Beginning in 2021, the F-22 has been seen testing a new chrome-like surface coating, speculated to help reduce the F-22's detectability by infrared tracking systems. 165-166. Front fuselage detail of an F-22. The effectiveness of the stealth characteristics is difficult to gauge. The RCS value is a restrictive measurement of the aircraft's frontal or side area from the perspective of a static radar. When an aircraft maneuvers, exposes a completely different set of angles and surface area, potentially increasing radar observability. Furthermore, the F-22's stealth contouring and radar-absorbent materials are chiefly effective against high-frequency radars, usually found on other aircraft. The effects of Rayleigh scattering and resonance mean that low-frequency radars, such as weather radars and early warning radars, are more likely to detect the F-22 due to its physical size. These are also conspicuous, susceptible to clutter, and have low precision. 167. Additionally, while faint or fleeting radar contacts make defenders aware that a stealth aircraft is present, reliably vectoring interception to attack the aircraft is much more challenging. 168-169. Avionics. An F-22 releases a flare during a training flight. The aircraft has an integrated avionics system where through sensor fusion, data from all onboard sensor systems, as well as off-board inputs are filtered and processed into a combined tactical picture, thus enhancing the pilot's situational awareness and reducing workload. Key mission systems include Sanders, General Electric and ALR-9 for electronic warfare system, Martin Marietta and AR-56 infrared and ultraviolet missile launch detector MLD, Westinghouse, Texas Instruments and APG-77 active electronically scanned array ESA radar, TRW communication, navigation, identification CNI suite, and Raytheon advanced infrared search and track IRST being tested. 170-171-172. The APG-77 radar has a low observable, active aperture, electronically scanned antenna with multiple target track. While scanned in all weather conditions, the antenna is tilted back for stealth. Its emissions can be focused to overload enemy sensors as an electronic attack capability. The radar changes frequencies more than 1,000 times per second to lower intersection probability and has an estimated range of 125 to 150 miles to 101 to 241 kilometers against an 11 square feet, 1 square meter target, and 250 miles for 100 kilometers or more in narrow beams. The upgraded APG-77V1 provides air-to-ground functionality through synthetic aperture radar SAR mapping, ground moving target indication, track GMTI, GMTT, and strike 154. The hour-90 for electronic warfare system, among the most technically complex equipment on the F-22, integrates more than 30 antennas blended into the wings and fuselage for all-round radar warning receiver (RW) or coverage and threat geolocation. It can be used as a passive detector capable of searching targets at ranges 250 plus nm, exceeding the radars, and can provide enough information for a target lock and cue radar emissions to a narrow beam down to 2x2 in azimuth and elevation. Depending on the detected threat, the defensive systems can prompt the pilot to release countermeasures such as flares or chaff. The MLD uses 6 sensors to provide full spherical infrared coverage, while the advanced IRST, housed in a stealthy wing pod, is a narrow field of view sensor for long-range passive identification and targeting. 173 to ensure stealth in the radio frequency spectrum. CNI emissions are strictly controlled and confined to specific sectors, with tactical communication between F-22s performed using the Directional Inter-Flight Data Link (IFDL). The integrated CNI system, which incorporates a MIDS-JTRS terminal, also manages TACAN, IFF including Mode 5, and communication through various methods such as Quick, Saturn and SINCARS, 170 for 175. The aircraft was also upgraded with an automatic ground collision avoiding system GCAS, 176, a CIP unit for the F-22. Information from radar, CNI, and other sensors are processed by 2 Hughes common integrated processors, THIP mission computers, each capable of processing up to 10.5 billion instructions per second. 177-178. The F-22's baseline software has some 1.7 million lines of code, the majority involving the mission systems such as processing radar data. 179. The highly integrated nature of the avionics architecture system, as well as the use of the programming language Ada, and 21 has made the development and testing of upgrades challenging. To enable more rapid upgrades, the CIPs were upgraded with Curtiss-Wright Open Mission Systems as well as a modular open systems architecture called the Open Systems Enclaveos orchestration platform to allow the avionics suite to interface with containerized software from third-party vendors. 30-181. The F-22's ability to operate close to the battlefield gives the aircraft threat detection and identification capability comparative with the RC-135 rivet joint, and the ability to function as a mini AWACS, though its radar is less powerful than those of dedicated platforms. This allows the F-22 to rapidly designate targets for allies and coordinate-friendly aircraft. 150 for 182. Although communication with other aircraft types was initially limited to voice, upgrades have enabled data to be transferred through a battlefield airborne communications node BACN or via JTIDS. Link 16 traffic through MIDS-JTRS. 118. The IEEE-139 for B-bus developed for the F-22 was derived from the commercial IEEE-1394 Firewire bus system. 183. In 2007, the F-22's radar was tested as a wireless data transceiver, transmitting data at 548 megabits per second and receiving at gigabit speed, far faster than the Link 16 system. 180. For the radio frequency receivers of the Electronic Support Measures ASM system give the aircraft the ability to perform intelligence, surveillance, and reconnaissance ISR tasks. 185-186. Cockpit of the F-22, showing instruments, head-up display and throttle top lower left. The F-22 has a glass cockpit with all digital flight instruments. The monochrome head-up display offers a wide field of view and serves as a primary flight instrument. Information is also displayed upon 6-color liquid crystal display LCD panels. 187. The primary flight controls are a force-sensitive side stick controller and a pair of throttles. The USAF initially wanted to implement direct voice input DVI controls, but this was judged to be too technically risky and was abandoned. 188. The canopy's dimensions are approximately 140 inches long, 45 inches wide, and 27 inches tall. 355 centimeters, 115 centimeters, 69 centimeters, and weighs 360 pounds. The canopy was redesigned after the original design lasted an average of 331 hours instead of the required 800 hours. Although the F-22 was originally intended to have a helmet-mounted display HMD, this was deferred during development to save costs. The aircraft is currently integrating the Scorpion HMD 85. The F-22 has integrated radio functionality. The signal processing systems are virtualized rather than as a separate hardware module. 190. The Integrated Control Panel (ICP) is a keypad system for entering communications, navigation, and autopilot data. To 3 in times 4 in 7.6 centimeters times 10.2 centimeters. Upfront displays located around the ICP are used to display integrated caution, advisory, warning, ICAW data, CNI data, and also serve as the standby flight instrumentation group and fuel quantity indicator for redundancy. 191. The standby flight group displays an artificial horizon for basic instrument meteorological conditions. The 8 in times 8 in 20 centimeters primary multifunction display PMFD is located under the ICP and is used for navigation and situation assessment. 6.25 in times 6.25 in 15.9 centimeters times 15.9 centimeters secondary multifunction displays are located around the PMFD for tactical information and stores management. 192. The ejection seat is a version of the ACES to commonly used in USAF aircraft, with a center-mounted ejection control. 193. The F-22 has a complex life support system, which includes the onboard oxygen generation system OBOGs, protective pilot garments, and a breathing regulator, anti-G brag valve controlling flow and pressure to the pilot's mask and garments. The pilot garments were developed under the Advanced Technology Anti-DSU ATAGS project and protect against chemical, biological hazards and cold water immersion, counter G-forces and low pressure at high altitudes, and provide thermal relief. 194. Following a series of hypoxia-related issues, the life support system was consequently revised to include an automatic backup oxygen system and a new flight vest valve. 114. In combat environments, the ejection seat includes a modified M for carbine designated the GAU-5. 195. The F-22 has 3 internal weapons bays, a large main bay on the bottom of the fuselage, and 2 smaller bays on the sides of the fuselage, aft of the engine inlets. A small bay for countermeasures such as flares is located behind each side bay. 196. The main bay is split along the center line and can accommodate 6 LAU-142. Launchers for beyond visual range BVR missiles, and each side bay has an LAU-141. Launcher. The primary air-to-air missiles are the AIM-120M RON and the AIM-9 Sidewinder, with planned integration of the AIM-260J ATM. 197. Missile launches require the bay doors to be open for less than a second, during which pneumatic or hydraulic arms push missiles clear of the aircraft. This is to reduce vulnerability to detection and to deploy missiles during high-speed flight. An internally mounted M6 or A2 Vulcan 20mm rotary cannon is embedded in the airplane's right-wing root with the muzzle covered by a retractable door, which remains closed when the cannon is not firing in order to minimize the negative effect the exposed muzzle on the aircraft's radar signature. 199. The radar projection of the cannon fire's path is displayed on the pilot's head-up display. 200. Although designed for air-to-air missiles, the main bay can replace for launchers with two-bomb racks that can each carry 1,000 pounds for 150 kilograms, or for 250 pounds 110 kilograms bombs for a total of 2,000 pounds 910 kilograms of air-to-surface ordnance. 200. In 2024, Lockheed Martin disclosed its proposed Mako hypersonic missile, a 1,300 pounds 590 kilograms weapon that can be carried internally in the F-22. 202 While capable of carrying weapons with GPS guidance such as JAMS and SDBS, the F-22 cannot self-designate laser-guided weapons. 203. F-22 with external weapons pylons. While the F-22 typically carries weapons internally, the wings include for hardpoints, each rated to handle 5,000 pounds 2,300 kilograms. Each hardpoint can accommodate a pylon that can carry a detachable 600-gallon 2,270 L external fuel tank or a launcher holding two air-to-air missiles. The two inboard hardpoints are plumbed for external fuel tanks. The two outboard hardpoints have since been dedicated to a pair of stealthy pods housing the IRSTN mission systems. The aircraft can jettison external tanks and their pylon attachments to restore slow observable characteristics and kinematic performance. 204. The F-22 underwent extensive testing before its service introduction. While the first production aircraft was delivered to Edwards AFB in October 2002 for IOTNE and the first jet for the 422nd TES at Nellis AFB arrived in January 2003, IOTNE was continually pushed back from its planned start in mid-2003, with mission avionics stability being particularly challenging, and 20 to 155. Following a preliminary assessment, called IOTNE Phase 1. Formal IOTNE began in April 2004 and was completed in December of that year. This milestone marked the successful demonstration of the jet's air-to-air mission capability, although the jet was more maintenance-intensive than expected. 211. A follow-on OT and EFOTNE in 2005 cleared the F-22's air-to-ground mission capability. 212. The first combat-ready F-22 of the first fighter wing arrived at Langley AFB, Virginia, in January 2005 and that December, the USAF announced that the aircraft had achieved initial operational capability (OC) with the 94th Fighter Squadron. 213. The unit subsequently participated in Exercise Northern Edge 06 in Alaska in June 2006 and Exercise Red Flag 07 at Nellis AFB in February 2007, where it demonstrated the F-22's greatly increased air combat capabilities when flying against Red Force aggressor F-15s and F-16s with a simulated kill ratio of 108-0. These large force exercises also further refined the F-22's operational tactics and employment. 53-214. The F-22 achieved full operational capability FOC in December 2007, when General John Corley of Air Combat Command ACC officially declared the F-22s of the Integrated Active Duty 1st Fighter Wing and Virginia Air National Guard 192nd Fighter Wing fully operational. 215. This was followed by an operational readiness inspection ORI of the Integrated Wing in April 2008, in which it was rated excellent in all categories, with a simulated kill ratio of 221-0. 216. The fielding of the F-22 with its precision strike capability also contributed to the retirement of the F-117 from operational service in 2008, with the 49th Fighter Wing operating the F-22 for a brief period prior to a series of fleet consolidations to reduce long-term operational costs. 217. Further consolidations to improve availability and pilot training were recommended by the Government Accountability Office in 2018. 218. Training. 2005. An F-22 of the 43rd Fighter Squadron flies alongside an F-15 of the 27th Fighter Squadron. The 43rd Fighter Squadron was reactivated in 2002 as the F-22 Formal Training Unit (FTU) for the Type's Basic Course at Tyndall AFB, and the first aircraft for pilot training was delivered in September 2003, following severe damage to the installation in the wake of Hurricane Michael in 2018. The squadron and its aircraft were relocated to nearby Eglin AFB. Although it was initially feared that several jets were lost due to storm damage, all were later repaired and flown out. 219. The FTU and its aircraft were reassigned to the 71st Fighter Squadron at Langley AFB in 2023. 220. As of 2014, B Corps students require 38 sorties to graduate, previously 43 sorties. Track 1 course pilots retraining from other aircraft also saw a reduction in the number of sorties needed to graduate, from 19 to 12 sorties. 221 F-22 students are first trained on the T-38 Talon trainer aircraft. Additional pilot training takes place on the F-16 because the aging T-38 is not rated to sustain higher G-forces and lacks modern avionics. 222 due to a lack of a modern trainer stand-in that can accurately emulate the F-22. The Air Force often uses F-22s to supplement training, which is costly, as the F-22 costs almost 10 times more than the T-38 per flight hour. 223. The upcoming T-7 Red Hawk features modern avionics that better approximate those of the F-22 and F-35. 224. This is scheduled to enter initial operating capability in 2027, several years behind schedule. 225. In 2014, the Air Force stood up the 2nd Fighter Training Squadron at Tyndall AFB, which was equipped with T-38s to serve as adversary aircraft to reduce adversary training flights on the F-22s. 226. To reduce operating costs and prolong the F-22 service life, some pilot training sorties are performed using flight simulators. 205. The Advanced F-22 Weapons Instructor Course at USAF Weapons School is conducted by the 433rd Weapons Squadron at Nellis AFB. 227. Initial operational problems. During the initial years of service, F-22 pilots experience symptoms as a result of oxygen system issues that include loss of consciousness, memory loss, emotional lability and neurological changes, as well as lingering respiratory problems and a chronic cough. The issues resulted in a fatal mishap in 2010 and 4-month grounding in 2011 and subsequent altitude and distance flight restrictions. 228. 229. In August 2012, the DOD found that the brag valve, which inflated the pilot's vest during high-G maneuvers, was defective and restricted breathing, and the OBOGS onboard oxygen generation system unexpectedly fluctuating oxygen levels at high-G. 230-231. A Raptor Aeromedical Working Group had recommended changes in 2005 regarding oxygen supply that were unfunded but received further consideration in 2012. 230-233. The F-22 CTF and 412th Aerospace Medicine Squadron eventually determined breathing restrictions as the root cause. Coughing symptoms were attributed to acceleration atelectasis in 23 from high-G exposure and OBOGS delivering excessive oxygen concentration. The presence of toxins and particles in some ground crew was deemed unrelated. 230 for modifications to the life support and oxygen systems, including the installation of an automatic backup, allowed altitude and distance restrictions to be lifted in April 2013. 235. Operational service, aerial port view of 2 aircraft in flight, one on top of the other. The bottom aircraft is a 4-engine propeller-driven aircraft, which is escorted by a jet fighter, an F-22 from Almendorf AFB, Alaska, intercepting a Russian Tupolev Tu-95 bomber near American airspace. Following IOCM large-scale exercises, the F-22 flew its first homeland defense mission in January 2007 under Operation Noble Eagle. In November 2007, F-22s of 90th Fighter Squadron at Almendorf AFB, Alaska, performed their first North American Aerospace Defense Command NORAD interception of 2 Russian Tu-95MS bombers. 236. Since then, F-22s have also escorted probing Tu-160 bombers. 237. The F-22 was first deployed overseas in February 2007 with the 27th Fighter Squadron to Kadena Air Base in Okinawa, Japan. 238. This first overseas deployment was initially marred by problems when 6 F-22s flying from Hickam AFB, Hawaii, experienced multiple software-related system failures while crossing the international dateline 180th meridian of longitude. The aircraft returned to Hawaii by following tanker aircraft. Within 48 hours, the error was resolved and the journey resumed. 239-240 Kadena would be a frequent rotation for F-22 units. They have also been involved in training exercises in South Korea, Malaysia, and the Philippines. 241-240-243. Defense Secretary Gates initially refused to deploy F-22s to the Middle East in 2007. 244. The type made its first deployment in the region at Al Dhafra Air Base in the UAE in 2009. In April 2012, F-22s have been rotating into Al Dhafra, less than 200 miles from Iran. 245-246. In March 2013, the USAF announced that an F-22 had intercepted an Iranian F-4 Phantom II that approached within 16 miles of an MQ-1 Predator flying off the Iranian coastline. 247. An F-22 refueling prior to combat operations in Syria. September 2014. On the 22nd of September 2014, F-22s performed the type's first combat sorties by conducting some of the opening strikes of Operation Inherent Resolve, the American-led intervention in Syria. Aircraft dropped 1,000-pound GPS-guided bombs on Islamic State targets near Tishreen Dam. 248, 249. Between September 2014 and July 2015, F-22s flew 200 for sorties over Syria, dropping 270 bombs at some 60 locations, 250 throughout their deployment. F-22s conducted close air support CAS and also deterred Syrian, Iranian, and Russian aircraft from attacking U.S.-backed Kurdish forces and disrupting U.S. operations in the region. 251, 250 to 253 F-22s also participated in the U.S. strikes that defeated pro-Assad and Russian Wagner Group paramilitary forces near Kashan in eastern Syria on the 7th of February 2018. 250 for 255, 256. These strikes notwithstanding, the F-22's main role in the operation was conducting intelligence, surveillance and reconnaissance. 257. The aircraft also performed missions in other regions of the Middle East. In November 2017, F-22s operating alongside B-52s bombed opium production and storage facilities in Taliban-controlled regions of Afghanistan. 258, 209. Proposed derivatives, the X-4 Manto, or multi-axis, no-tail aircraft, was a planned experimental aircraft based on the F-22 with enhanced thrust vectoring controls and no aerodynamic surface backup. 281. The aircraft was to be solely controlled by thrust vectoring, without featuring any rudders, ailerons, or elevators. Funding for this program was halted in 2000. 282. The FB-22 was proposed in the early 2000s as a supersonic stealth regional bomber for the USAF. 283. The design went through several iterations, and the later ones would combine an F-22 fuselage with greatly enlarged delta wings and was projected to carry up to 30 small-diameter bombs to over 1,600 mi 3,000 kilometers, about twice the combat range of the F-22A. The FB-22 proposals were cancelled with the 2006 Quadrennial Defense Review and subsequent developments, in lieu of a larger subsonic strategic bomber with a much greater range. This became the next-generation bomber, although it would be rescoped in 2009 as the long-range strike bomber, resulting in the B-21 Raider. 126, 285, 286. In August 2018, Lockheed Martin proposed an F-22 derivative to the Japan Air Self-Defense Force JSDF for its sixth-generation FX program. The design, which was later also proposed to the USAF, would combine a modified F-22 airframe with enlarged wings to increase fuel capacity and combat radius to 1,200 mi 2,200 kilometers, as well as the avionics and improved stealth coatings of the F-35. 287, 288. The proposal was ultimately not considered by the USAF or JSDF due to cost as well as existing export restrictions and industrial workshare concerns. 289, 290. Operators, F-22 from Tyndall Air Force Base, Florida, cruising over the Florida Panhandle. An F-22 landing at Holloman, AFB, New Mexico. An F-22, based at Elmendorf, AFB, Alaska, over mountain terrain. An F-22 during in-flight refueling with a tanker aircraft. F-22 with drop tanks in transit to Kadena Air Base, Japan, from Langley, AFB, Virginia. The United States Air Force is the only operator of the F-22. As of August 2022, it has 183 aircraft in its inventory. 37.